Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome, or hopefully welcome back to the Reliability Matters podcast. I'm Mike Conrad, but you already know that. And what you also are figuring out is I'm not in my normal studio. I am in sunny Anaheim, California at the IPC APEX Expo. My friend and colleague, Trevor Galbraith from Global SMT Magazine, has graciously invited me into his dominion here in his traveling studio to record the Reliability Matters podcast. And this wouldn't be possible without his generosity and the technical expertise of Summer and Jen, who are pushing the buttons at all the right times, making sure that we look as good as possible, and they're all doing a happy dance off camera here. So I love it. Anyway, thanks for being here today. This is going to be a little shorter episode. I'm going to have multiple conversations with multiple people, and so it's going to be kind of a tapas bar of conversations. And for the first conversation, I have Gerald Gardner, who is the global product manager for a company I'm quite certain you've heard of. In fact, if you haven't heard of it, I'd question if you're even involved in the electronics industry, and that is Weller. Welcome.
Thanks for having me on this.
It's a pleasure for you to be here. It's a pleasure to have you here. I hope it's a pleasure for you to be here.
No, for sure. Yeah.
Let's talk about soldering irons for a little bit. Is that all right?
Yeah.
Okay. You're most well known for soldering irons. I know you do other things as well, like fume extraction and stuff. But soldering irons are kind of your bread and butter. That's what your reputation is set off of. When I was a kid, my only contact with a soldering iron was from my father's tool chest, and it was a soldering gun, which I didn't know there was a difference between a soldering gun and a soldering iron, but it looked like a gun, right? It had the shape of a gun, and you just click the trigger, and the tip instantly heated up. Yeah, I don't even know what temperature. I don't think anyone knew what temperature. I don't think there was a set temperature.
It melted the lead at the time.
Melted the lead at the time, and then we did our solder sculpting. We probably really didn't do soldering. I don't think we melded two metals together, but I think we just glued one on top of the other. But it worked. That was my experience.
We still sell those today.
Yeah, well, I'm sure they have a purpose because they're instant, but soldering irons today are much more sophisticated than they used to be. And one of the things that I've noticed, at least from a layman's standpoint, is, because I'm not a soldering technician, is temperature control. Every soldering iron I see now, from low price ones to very expensive ones, have some kind of LED indicator, and you can turn a dial and program a temperature. How, in today's modern assemblies, highly miniaturized, more delicate, clearly, than through-hole components were in years past, how important is temperature control, and how does temperature control relate to quality and therefore reliability?
Yeah, so I mean, we all know that the control of the temperature is vital. I mean, the components are so sensitive these days. You got to get the temperature up a little bit higher now because of the lead-free solder, and it's got to just melt to make that joint. So you don't want to overshoot that at all. Fortunately, the Weller stations, we have really good temperature control in that we have these active tips, these active cartridges, where the heating element and the temperature sensor are all part of the same thing. But the tip actually has electronics in there, and what we're able to do is automatically calibrate with our calibration unit to get the temperature spot on. So even if we picked up that there was a temperature difference, we can automatically, convert that to hit the temperature, on the spot. So that's what the guys need
today. Yeah. So on the same subject of temperature, lead-free alloys often require a higher temperature. To reflow. I'm in the cleaning world. That impacts cleaning. Temperature is not our friend when it comes to knock-on effects.
And for tip life as well.
That's exactly where I'm going to go.
Yeah.
So what features in modern soldering irons help ensure strong, reliable joints while minimizing the risks of like oxidation and thermal damage and maximizing tip life and things like that? What are the tricks up Weller's sleeves there, and the industry sleeves?
Yeah, I mean, there's a lot of things, because now with active tip technology, the tip is becoming more and more expensive, because you've got the heating element, you've got the sensor, and the tip itself. So obviously you want to maximize that tip life as much as you can, and so we incorporate several things. The fact that we have the active tip has the sensor right there in the front of the tip, which means that it can automatically respond, instantaneously respond to that temperature demand. Okay, because you've got this higher performance, you can then lower the temperatures, because the temperatures are the enemy. I should have said it's the enemy to the tip life. So that's the one thing. So we're able to solder at lower temperatures. Because it's a higher performer, we're able to put a little bit. We're able to play with the iron layer to improve tip life through the sacrificial layer. And then another aspect around tip life extension is, choice of fluxes and solder wires. But also we have an automatic tip cleaner. Now that is great because you've got better control of now the cleaning process. So you can clean the tip within a second. What that does is it takes away all the old tin. Okay, but what it does is it exposes the bare metal now. So you've got to clean that tip just in a second. 2 seconds, you're not taking away too much material. 1 second, and then you have to retin it, put it back in the stand, and
so it's a little bit tribal. That part of soldering or maintenance on your soldering iron or best practices can be a little bit tribal. You kind of have to have it's a science and an art kind of mixed together.
Yeah, well, I mean, soldering technicians are artisans.
They are.
Yes. There's a skill to it, and there's habits, and they've got to, and unfortunately, there are bad habits, and we've got to, encourage them to have better habits. Aren't
we all? Going back to my youngster days with the soldering gun.
Yeah.
The tip size was the tip size. I don't think it was a choice, at least back then. How important is it to select the most appropriate tip for a specific job? What are the factors that drive specific tip selection?
So there are several. I mean, the tip, the geometry, the size of the component, the size of the pad, how much access you actually get to where you need to go with the tip. So obviously, these days with these small resistors that we have and these really tiny leads, you want to go with a very fine tip. Often also, you might be a really dense board, highly populated. You can't get in there very well. So you want, often it's the tip, but it's also the heating element itself, the shaft, the grip. You want a really small, fine grip to get into these small places. That's on the small side. On the larger side, you don't want a tiny tip on a huge, big heat sink of some sort. So on the one hand, you want to get the biggest contact area that you can, but still get into where you need to do the job. And It's all about the heat flow. I mean, the tip is the bottleneck to the heat flow. So maximize it without touching, either side of the pad or, things that you don't want to touch.
Yeah, I've seen some tips in our industry. I'm not sure what kind of soldering they're doing, but the tip looks like the end of a crowbar. It's very chiseled, and it's flat and it's wide, maybe 1/4 inch to 1/2 inch wide. And I'm thinking, what kind of component requires that? But there's a lot of power electronics and things like that have huge ground planes and that are just giant heat sinks. So I guess in that environment, you need something just short of a blowtorch, to heat up that material. As we finish up, what are some of the most common mistakes that you see someone who is searching for soldering equipment, soldering irons, or I'll keep it with soldering irons for right now. what are the most common mistakes they make when selecting an iron?
Well, sometimes they may go to the Home Depot or one of these places and try buy a $20 or on Amazon or
and they may see a familiar brand that like a brand that is popular in our space, but that is a professional version of that brand, and what they're seeing is a amateur version, consumer version of that. But they may think, well, I know that brand. Yeah. It's so much cheaper at Home Depot, than from my distributor.
Yeah. So we started the conversation talking about temperature control, and the cheaper irons don't have that temperature control. So they will melt the solder, but like your gun, you have no idea what that temperature is.
Right.
For doing microelectronics, it's not ideal. So any soldering iron that has temperature control or some confidence that the temperature is being controlled, however the system is fine. That's one of the biggest mistakes I would say.
I'm well known for asking multiple last questions, but this will probably be my actual last question. Beyond soldering irons, I alluded to the fact that one of the products you also make are fume extractors. So soldering creates quite a bit of fumes. I mean, you're burning flux and you're melting metal, and that's going to create fumes. Those fumes, I assume, have some degree of harmfulness to them in volume, or at least an irritating factor to them. Tell us what fume extraction is. I know in the simplest terms, you're sucking the air out, but you got to move it somewhere, and one would assume it's also filtered. So tell me what a fume extraction is today, what a fume extraction system is today, and why it's a value-added item to consider when setting up a soldering line, a manual soldering line.
Okay, so fume extraction is really, it is vital. It's wherever you've got a soldering iron, you should have some means to get rid of that smoke. They've done studies. The way you sit over the soldering iron, your body is blocking the edge of the bench, so the air rises with the heat, with the smoke, and it's replaced by the air from the back. So that smoke goes directly into your face. I mean, you think it's coming to your face, and it actually is.
It is. Yes.
So these little bench fans, they're great at taking the smoke away from your face. Don't get me wrong. And that's fine for if you're working in your garage at home, because there's nobody else in the room. And invariably, you're soldering for a little bit, the smoke's away from you, and it'll disperse and just, But in a professional environment, you can't have that. You're going to be sucking the smoke away and throwing it at your colleague, and
that's the ultimate secondhand smoke.
And if
it's applied to this,
and if it's a colleague that you like, it's not so good.
You may not get a second date. Yeah,
exactly. So look, at least it takes the smoke away from your face, which is good. But now you got to do something with that smoke. So the first thing is the fume extractor must take the smoke away, and then it must do something with that smoke, purify it, take out the particles, take out the gases, put it back into the environment. It's really is vital. We've done a test where we've just taken like a mesh, like this microphone, and within half an hour you see all this gunk sticking to it, and that stuff is sticky, residues.
Right.
Oh, in your industry, we
have same
well aware of.
Yeah, sure.
And that's going to be sticking in your lungs. Wait, if you have a little bit of it, fine. Your lungs sort of are self-flushing. That they will get it out. But if you're exposed to a lot of that, you really don't want that.
If you're going to bring smoke into your lungs, at least let it be a fine cigar, because there's no. At least you get a value out of that.
Well, some people do like the smell of some of these fluxes,
Well,
I don't recommend.
I've been in so many. I started in this industry 40 years ago this year, in 1985, and I'm like that line out of Apocalypse Now. I love the smell of napalm in the morning, from the old soldier, the old Marine. Yeah. I'm that way with electronics. I can smell flux. I can smell cleaning. I can smell soldering. Yeah. And it's a unique smell. And once you smell it, right? Yeah. Your brain.
Well, we also sell into other industries like beauty salons, for example.
Oh,
and I often wonder.
Smell there.
Yeah. I actually wonder, like, do they want the smell to go away, or are they actually getting a kick out of the
They're all high.
instead of floating around?
They're all high. Yeah, exactly. Well, Gerald, thank you so much for this brief conversation on what goes on kind of behind the scenes in the selection process and all about soldering. Thanks for not making too much fun of me over my soldering gun.
Hey, no worries.
Solder sculpting career.
At least you had one as a kid.
I had one. Yeah, exactly. It was the start. And thanks for being here. I appreciate it.
And thank you very much for talking to me.
My pleasure. And for my viewing audience or listening audience, if you're watching this live, I will be right back. Welcome back to the Reliability Matters podcast. We are still in sunny Anaheim, California. We are still in the Global SMT booth. And my best friends behind the camera, Summer and Jen, are still pushing the buttons at all the right times. So thank you, ladies, for all your work. My guest now is Mike Young. He's CEO of SASinno Americas, a manufacturer of wave and selective and robotic soldering equipment. Hi, Mike. Thanks for being my guest.
Hey, thank you, Mike, for having me.
Thanks for being voluntold, or whatever applies here. I'm
Either way,
at least get off your feet for a...
I am.
Right.
It's a comfortable chair, and I appreciate
Mike's
like to do this.
You talk to me for an hour. It's fine. I'm off my feet.
Right.
So
this is a comfortable chair.
Want to talk soldering?
Absolutely.
All right. So I got in this industry in 1985 and selling drag soldering machines, which was an alternative to wave soldering machines, supposedly a lower price alternative. And of course, I started in 85, and within a few short years, what came on the scene? Surface mount. What doesn't work with surface mount? Drag soldering machines or dip soldering machines. Turns out the bodies of the components don't like to go under the, into immersion, 500-degree solder. And I always found wave solder machines in my kind of naive days when I was fresh in this industry. I thought they were a combination of high-tech and just brute force. I mean, it's melting metal and pumping it up over and creating a wave, just overfilling a tank. Just seemed a combination of high-tech and barbaric almost, right? Like a volcano in a very high-tech environment. But it worked. And then over the years, I saw some innovations. One of the companies decided to mix oil with the solder to minimize dross, and then there were all these dross inhibitors, these little wax products you could put on, and all this stuff. And then wave solder machines got very sophisticated and a lot more technology, and then surface mount comes along, and all of a sudden everyone's buying ovens.
Yes.
Although wave soldering machines are still relevant today because through-hole hasn't gone away. And
in fact, it's growing.
Yeah, well, there's certain like connectors and interconnects and stuff like that are largely still through hole.
Yes.
And I don't think you would get the same bond strength if you had basically one of these tank connectors. I call them tank connectors. If they were surface mountable, I think you'd just be ripping everything off ripping the pads off the board. Let's talk about the advances over the years from my first introduction to wave soldering machines back in the 80s till today. I mean, you still have a pump, you're still pumping solder.
Yes.
Different alloy today. But what technically has changed over the years, over the evolution of wave soldering machines that makes them what they are today?
Well, that's a great question. I remember those early days in wave soldering as well. Well, actually, they weren't the early days in wave soldering, but my early days in wave soldering. I got out of the Navy and went to work for a wave solder manufacturer that also made other items as well. And I can remember being introduced to the wave solder line and being told that this won't be here much longer because surface mount is coming. This is the very, very early 90s, and here we are 30-plus years later.
Was it Mark Twain or Yogi Berra that said, rumors of my death have been greatly exaggerated? It's one of the two.
I think it was Yogi Berra.
Yogi Berra, yeah. And you're right. That's what happened with soldering machines, with wave soldering machines.
Yeah, it has come full circle. So there are some new innovations that you can find in wave solder. There's some new things that we're doing. Some of the other companies that are out there are doing some new things as well. We went back from impeller pumps. Do you look at electromagnetic style to try to pump that inside of a wave? There's innovations like that. I can remember back in the early days of doing hot air knives. Now looking at other ways to do that, ways to reduce dross. But at the end of the day, it's still the same process. It's still a wave solder process. One of the things that we focus on for innovation is looking about how to make wave solder a much lower or easier maintenance process, because it is what it is. Like you said, you're diving a board inside of a hard pumping wave. There's a lot of dynamics to exactly how that wave is supposed to flow, but you're pumping a board into that wave. So how can you do that? Still keep it a good process, a viable process, but how can you go back to the machine and make the machine a process that is, by its very nature, a high maintenance process, and take a lot of the maintenance out of it? And so that's what we've been focusing on for a good period of time now. What we've also done is jumped inside the machine and said, okay, how can we make the machine more intelligent? How are we pumping out new information? So we've come out with our new iDesign machine. We've got an EWA machine, the E's for an economy. We've got an IWA machine. The IWA machine, we focus in a standard machine, we're automatically doing selective fluxing. Beyond that selective fluxing, we're also automatically inside the standard machine looking at the consumption, how much flux are we using. We're looking at the power draw of the machine, how much power are we using throughout the machine. We're looking at the solder consumption of the machine. So at the end of each day, you'll get a consumption record back that tells you exactly how much of those that you've used. We've also done it a little further. In the past, if you had a heater going out in a preheater, you had a heater going out in your solder pod, you knew it when your process went bad. And so today we started monitoring the current draw. So if we see a change in that current draw, we know that heater's going to go out. It might not be today, but it's going to be in the next couple of weeks. So what can we do? We can make sure we have a heater on the shelf. We can make sure we've scheduled the maintenance to do it.
Yes,
We're increasing that time between failure.
Predictive versus reactive.
Exactly. So we're trying to help give customers that data so that they can do that. And the only way we can do that is through an intelligent design machine that's actually monitoring those things. Innovation-wise, remember back to the days when they first started doing wave height monitoring. So we're doing that, but we're doing it a little bit different way. We're doing it in a non-contact way between boards, so we're constantly checking it, but we're not touching that wave and displacing it so that we're messing with our process at all.
Right.
So there's a lot more that we're doing today, but at the end of the day, you're still sending a board through
It still has that Neanderthalic almost,
Yes.
just pump metal over a mountain, kind of thing.
Yes.
So two of the changes I've seen over the years, again, from a 30,000-foot view perspective, is in the flux application method. Back in my early days, it was all foam fluxers. And foam fluxers had that, you trough a whole bunch of flux onto the top side of the board. As you hit that wave, the wave has to be, or the foam head has to be at least as high as the board. Usually it's set a little higher, and then you just plow through it, and then you're putting gobs, I think that's a technical term, gobs of flux, and it would come off and start dripping over the preheaters, which in some cases, depending on the technology back in the day, the flux would drip on it and catch fire. Those were things that happen.
Yes.
But today, no clean flux works with the proper application of activating temperatures. So if flux happens to get onto the top side of the assembly through either an application method, or sometimes assemblers will spray a little flux on the top side of an assembly to improve topside wetting. If you have like a thermal mass, big ground plane or something, it'll help. If you don't have adequate preheat, because the wave is never going to hit the top of the board, or at least it shouldn't hit the top of the board, you may end up with no clean flux that hasn't been properly activated, which means it's not really no clean at that point. It's bad actors haven't been encapsulated or burned off, and they will create potentially electrochemical migration events if not cleaned. So has there been, I think the answer is yes, but so if so, tell me what technology improvements have been made to control, I'll dare say, a profile, although not a profile like we would think of in an oven, which is to the degree, but in terms of controlling the profile or the ramp rate or the effectiveness of preheat, both top and bottom, in a wave solder machine application today.
So that's a good question. In the past, you talk about profiling reflow ovens. So when you profile a reflow oven, you're basically taking the solder paste, whatever solder paste it is the customer's choosing, and they're taking the principles of that solder paste, and you're using it to say that this needs to have so much of a soap, so much of a ramp, so much of a peak, and you're trying to emulate that exactly through your reflow oven. The truth is, it works the same way for wave solder, except for you're taking the flux. So every flux vendor has a little bit different profile they want that flux to see before it activates, before it goes over the top of it. So, there's a few ways you can do that. There are a couple of good players out there that provide profiling units that you can set up internal to the system that's constantly monitoring how that profile is taking place inside. We've teamed up with some of those, and very happy to present that to a customer because it's a great solution to do that. And it's an external solution to us, and many of the other vendors of wave solder do the same thing. But at the end of the day, what matters is what temperature is that board seeing right before it hits the wave. So in our I-version machine I was talking about, we installed a parameter that's basically looking right at the board right before it hits the wave. And if we tell that board, that system, that it needs to be between this temperature and this temperature, and we're watching that to happen, if that board's not at that temperature, we can shut the wave off. The board comes on out, and we can start over without having to start with a board that's not been properly soldered as it went through to begin with. Take it a couple steps back to, you talk about the nastiness inside of a wave solder machine. Those preheaters on the top side, you've opened up any machine that's been in the field for a long time, and you see that nastiness across the top side of the preheats. When we go back to the maintenance things that we look to do, if you go check our machine out in our booth, you can actually unplug the preheat, has one plug on it, you can take the preheater all the way out. But probably more importantly than that, because if you're doing that, you're typically changing a blower, changing a heater. Hopefully that rarely happens. But more importantly than that, the plate right above it, where the heaters are sitting below, is a slide plate. So you can reach inside of it, slide it right out, take it over to a cleaner, clean it off, slide it right back into position, and you've taken all of that nastiness up off of it. So, kind of twofold there. One is how do you monitor that process to make sure your process is what it's supposed to be? And we have a few methods to be able to do that. And second is how do you maintain that nasty thing that is flux? And going back to no cleans and water solubles, depending on the industry you're looking into, especially when you're looking at manufacturers like the military industry, they're still going back to those water soluble high rosin nasty fluxes, and they get a great soldering point out of it, even better than some of these really well formulated no cleans. But the process you have to do afterwards to get that off, you know better than me.
Pay the price, yeah.
How hard that is to get that off and make it clean again. So there's a lot you can do with the flux side of things, and the flux is more important than people realize in the wave solder process if they've not been doing it for a long time.
Last important question. SASinno is an interesting name. Where does that come from?
Smart and steady innovation.
Okay. I love companies that have an interesting story name behind it. So, A for effort there.
Thank you.
Good. Mike Young, CEO, SASinno Americas. That tells me there's more than SASinno.
SASinno is a global company.
Okay.
Yes, we're from the Americas to Asia to Germany to the UK. Europe. We're everywhere.
Well, CEO of the Americas version of SASinno, thank you very much for being my guest today on this short episode of Reliability Matters. I appreciate your insight.
Thank you to you and to Global SMT for having me on.
Oh, it's certainly been my pleasure. For my viewing or listening audience, this is a short episode of Reliability Matters. Thanks for listening or watching. Be sure and subscribe to Reliability Matters to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every single month. If you'd like more information on the Reliability Matters podcast, you can visit, stand by, reliabilitymatterspodcast.com. It's that easy. So thanks again for watching. I really appreciate you being part of our show. Until I see you again, stay reliable, stay clean, do everything right, and I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.